Hello everyone, happy to see you here. Welcome back to my channel Higher Mathematics. Today we have a great cubic equation, x cubed plus x squared equal to 36. We need to solve this equation for x. So if you have your solution, your approach, you can also write it in the comments below, and then we will check our answer. So it will be really interesting. So first of all, let's write the 36 on the left side. So this is our first step. So we have x cubed plus x squared minus 36 equal to 0. Okay, this is our equation. Right now, instead of the 36, I suggest you to, because there are a lot of ways how can we solve this equation. I'm going to show you this one. This is the easiest one. Instead of the 36, let's write 27 plus 9. A lot of students may be asking why we should write it. Let's look at it. So 36, of course, there are a lot of ways how can we express the 36. We can express it like 20 plus 16, 18 plus 18, something like that. A lot of ways, yeah, but the best way to express this is to write as 27 plus 9, yeah? And a lot of students might be asking, why 27 plus 9? 27 can be written as 3 cubed, and we have cube right here, so maybe somehow we can group it, and 9 can be written as 3 squared. So we also have x squared, so maybe we can group it, okay? So let's start with it. Instead of 36, let's write 27 plus 9, okay? So we have x cubed plus x squared minus 27 plus 9. 27 plus 9 equal to 0. Right now, let's open our parentheses real quick. So we have negative, so we need to change this sign to the opposite one. So we have x cubed plus x squared minus 27 and minus 9 equal to 0. Okay, what are we going to do? What are we going to do next? As I said before, instead of 27, we write 3 cubed. Instead of 9, we write 3 squared. So we have x cubed plus x squared minus 3 cubed and minus 3 squared equal to 0. And right now, as I said before, we have x cubed and we have 3 cubed. So right now, in the next line, let's group it. And we have x squared and we have 3 squared. So we can also group it. Okay, let's do it right now. First of all, let's group cubes. So x cubed, we have minus 3 cubed. This is our first parenthesis. So x cubed minus 3 cubed. X cubed minus 3 cubed. And in another parenthesis, we have plus x squared minus 3 squared. So we have x squared minus 3 squared. And right now, let's look at this question from a different angle. What do we have right here in this parenthesis? We have difference of 2 cubes. What do we have right here? We have difference of 2 squares. And let's remember these formulas. Let's do it right now. So for example, let's remember first of all difference of cubes. So a cube minus b cube. A cube minus b cube equal to a minus b. Yeah, these are according to our formula, a minus b times a squared plus ab and plus b squared. Okay, this is our formula, difference of 2 cubes. Right now, let's remember, this is maybe the easiest one. Everyone knows about this formula. We have difference of squares because we have difference of squares right here in this parenthesis. So we have a squared minus b squared, according to school knowledge, equal to a minus b times a plus b. Okay, so we know everything. We know difference of squares. We know difference of cubes. So right now, let's expand it. Let's express this. First of all, in terms of cubes. Yeah. First of all, what do we have? X minus 3. So let's apply this and this formula. So x minus 3. And in another parenthesis, x squared plus 3x and plus 9. The next thing we have plus x plus 3, x minus 3, or x minus 3, x plus 3, doesn't matter. X minus 3, x plus 3. So we expand it in terms of these two classic school formulas, difference of cubes and difference of squares. So I hope you understand my solution until this moment. So I hope you understand it. What we're going to do next? Right now, let's look at this question from a different angle. We have a lot of parentheses, x minus 3, this one, but the main thing, x minus 3 is a common with this x minus 3. So basically, we can actually factor this x minus 3 as a common. So let's do it right now. X minus 3, we factor it. X minus 3, we factor it. And in another parenthesis, what do we have? I just use these type of brackets. We have x squared, so this expression, so x squared plus 3x and plus 9. Yeah, we can actually write it like that. And we have plus this expression, plus x plus 3. Okay, so plus x plus 3. So I just used the parentheses because I want you to understand how do we split it, how do we separate these parts. So this is our first branch and this is our second branch, but we need to simplify this. So actually we can get rid of this parenthesis. Yeah, we can actually get rid of it because we have right here all the time positive sign, so we can actually get rid of this parenthesis. So the first parenthesis x minus 3 without any changes, so x minus 3 right here, and in another parenthesis we can actually add all of this because we have x squared without any changes because we don't have squares. 3x plus x equal to 4x, so plus 4x, and plus 9 plus 3 equal to 12. So we can actually say that we factor our question. We have first parenthesis and another parenthesis. So as I said before, whenever we have expression with the product, yeah, we have a product of two parentheses and this expression is equal to 0, so it means that the first parenthesis is equal to 0, so x minus 3 is equal to 0. This is our first branch. Or another parenthesis equal to 0, x squared plus 4x, so x squared plus 4x and plus 12 is equal to 0. So we have two branches, first one and the second one. So for example, let's solve this first branch real quick, instantly, because x first equal to 3. We can solve it without any problems. This is our linear function, x first equal to 3. Second branch, we have a quadratic equation. This quadratic equation should be equal to 0 because we have a product of two parentheses. But let's see, maybe this is not equal to 0. Maybe this equation doesn't have roots. So right now let's solve it. First of all, there are a lot of ways how can we solve this question, but I prefer this one, the basic one, method of coefficients. So a equal to 1, b equal to 4, and c equal to 12. Yeah, really great. What we're going to do next? The next thing, discriminant. We can actually plug in this discriminant into our formula, x second and x third, but I prefer to solve this separately. I just prefer solving this question first of all with discriminant. So we have b squared minus 4ac equal to b squared 4 squared minus 4 times a times 1 times c times 12. And as a result, what can we get from here? We have 16 minus 4 times 1 times 12 equal to 48. So our discriminant is equal to minus 32. So it means, like from on the first side, it means that we don't have right here roots, and this is a correct, but not a fully correct if you're talking about like a statement. This equation doesn't have roots. This equation does have roots, but these roots are complex. So discriminant is less than 0. So it means that in this branch we have two complex roots. Okay, we have two complex roots, and let's solve it. We have x second and x third. Yeah, we have x second and x third equal to, we have minus b plus minus square root of discriminant and all over 2a. Let's plug in everything we know into this formula. So minus b minus 4 plus minus square root of discriminant square root of minus 32 and all over 2 times 1. Okay, really great. Equal to, as a result, we have minus 4. This expression right here, square root of minus 32. Let's express this, so this square root of this minus 32, let's express as minus 1 times 2 and times 16, yeah, and all over 2. And a lot of students might be asking, why do we express it like that? Because there's like really great property. This property looks like that. So whenever you have a square root of a times b times c, this is equal to square root of a times square root of b and times square root of c. Okay, so we can actually split it. Let's do it right now. We have minus 4 plus minus square root of minus 1 times square root of 2 and times square root of 16. All over we have 2. Yeah. What we're going to do next? The next thing, of course, square root of 16 equal to 4, square root of minus 1 equal to I, so we can actually write it as minus 4 plus minus 4i square root of 2, something like that, all over 2. And the final step, of course, this is our root, but we can actually divide all of this by 2. We can divide this expression, this value by 2. So as a result, we have minus 2 plus minus 2i square root of 2. Okay, really great. Really great. So right now, let's write our final answer. So these are our complex root. This is our real part, this is our imaginary part with this unit I. Okay, so right now let's write our final answer to this question. So our answer, x first equal to 3, x second, let's go with the positive sign, equal to minus 2 plus 2i square root of 2, and x third equal to minus 2 minus 2i square root of 2. Yeah, this is our answer. These two roots are complex root, and this one root is real number root. So we have 3 roots and 3 roots in total. 2 complex and 1 real number root. In the end, let's check real quick our x first equal to 3. So this is our equation, x cubed plus x squared equal to 36. Let's plug in this x first equal to 3. Yeah, so we have our check. So we have 3 cubed plus 3 squared equal to 36. So 27 plus 9 equal to 36. 27 plus 9 equal to 36, so everything is great. This root is absolutely correct. And even if you have a problem with this type of questions, I'm going to give you one really important hint, because a lot of students might be thinking, okay, how many roots do I have right here? Because when they see, for example, equation, they might be thinking, I solved this question with 2 roots, maybe I have the third one, and it turns into a big argument. My quick tip, just scan what is the highest power, because according to a fundamental theorem of algebra, if you're talking about 3 as the highest power, so it means 3 roots in total, and we have exactly that case, 3 roots in total. But we don't know how many real number roots, how many complex roots, but actually 3 roots in total is a correct way to start this solution. Okay, 3 as the highest power, so 3 roots in total, and we have exactly that case. Yeah, so this is my solution to this question. I really hope you understand it. If you have problems, if you have any question, write a question in the comments below. It's also really interesting to exchange information, because there are a lot of teachers, a lot of students here, and I really appreciate when you exchange your thoughts in the comments below, when you help each other. It's also really great that we have this type of community on my channel. I also really appreciate it, and I want to genuinely say thank you for that. It's also really great nowadays to be here and to learn math and to practice math, because it's also it's a really great science, and it's a really great branch to do this. So yeah, this is my solution to this question. Also write your thoughts, write your notes in the comments below. Also write your questions, write your assumptions, and of course, if this video is helpful in any way, don't forget to leave something, to write your response. It's also really great that you leave your feedback. It's also really kind of you when you learn, when you leave something, and when you leave a comment. It's also really great to see that this video is helpful, maybe for one person, maybe one student to learn something, and they do really great on exam. It's also really great, and that's why I do this. I just want you to learn something and to know something new. It's also really great for everyone. Yeah, so this is my solution to this question. I want to say thank you for watching, thank you for everything. It's also really great to be here and to do math for everyone. So wish all the best in your life, take care of yourself, and have a great day. See you in the next videos.